So now let's talk about the gradient or graded coating. So the arrangement looks something like this. This is our substrate material, and so graded coating means gradual variation of composition from substrate to the top surface. So the main advantage of this configuration is a gradual transition in properties. So we start with a ductile substrate, and we can move gradually to a harder brittle coating. So in this way we avoid stress intensification, which is typically occurring when we combine a ductile material with a hard brittle coating, which is an additional source of failure risk. So how can we produce these gradual coatings? As we mentioned, the most typical method is the generation of nitrided or carburized profile, because we have a gradual variation of the nitrogen or carbon content moving from the surface to that, and we have corresponding hardness gradient. So it is possible to generate this variation over a larger depth, so it is most efficient way. We can produce graded composition in PVD technique. We mentioned, for example, production of nitrides as a wear resistant coatings. So how can we produce these nitrided layers? So nitrided layers can be produced by example of by taking an example of reactive sputtering. So this means that we fed the combination of argon and nitrogen to our chamber, and we define a proper nitrogen flow rate in order to expel titanium atoms from the target, and titanium atoms combines with the nitrogen atoms coming from the gas, and we produce our nitride layer on the surface. Now the next question is that what happens if we remove nitrogen and we only supply argon in our chamber? So we have a titanium target, and we produce a titanium deposit on our surface. Then we can start our process by depositing thin titanium layer. Then we increase progressively the flow rate of nitrogen, and we increase the amount of nitrogen embedded in our titanium layer until we achieve the desired nitrogen flow rate to grow the nitride layer. So then actually we produce graded coating with a gradual transition from our metallic layer up to the nitride layer. Titanium as a metal is highly ductile, so it matches well the properties of our substrate, and we have gradual transition in composition without any sharp interface in between to minimize any stress interfacial effect. So what is the main limitation of this approach? Again, the thickness of this film is in the range of some micrometers. So it is much thinner compared to the nitride layer, where hard depth is in range of 100 micrometers. So the load bearing capacity of a nitride layer is much larger. But through this approach, our graded, for example, titanium nitride layer, we can achieve much better adhesion compared to this single layer. Examples of graded surface layers are nitrided and carburized layers commonly produced on steels. So many forming tools and machine components take advantage of these treatments.